All right, welcome to lecture 20. And in lecture 20, we're going to keep talking about electron configuration. So you heard a little bit about it in the last lecture, but we need more details. There's more little things to know, and I want to make sure you have some more examples of that. So let's go ahead and get started. So in this lecture, it's going to be divided up into 3 parts like normal. The first 2 will be on electron configurations. And then the last part, we're going to move on to like another topic, not really a related topic. It's called periodic trends. So that'll be in part C. Okay, let's get going. Okay, so these are the electron configurations we did in lecture 19. All right, so what's an electron configuration again? It's just a way of telling you where are the electrons in an atom? What shells have electrons in them? All right, so we're going to do some more examples, and ultimately we're going to see how this relates to like the periodic table and stuff. So before we get into any of that, let's just do a few quick review questions. So these are the shells, right, that we fill up, and as we talked about last time, you start here, you're going to fill up 1s, then you're going to fill up 2s, 2p3s, 3p4s, and so on. Now, let me ask you a couple of questions about that. First off, s's. How many electrons can fit into an S subshell? S's go to 2. All right. Maximum electrons is 2 in an S. How many electrons can fit in a P subshell? Any P? P's go to 10. Oh, sorry, 6. I keep saying that wrong. All right, P's go to 6. All right, and then finally, how many electrons fit in a D subshell? D's go to 10. All right, maximum of 10 electrons. Now, again, I'm not bringing this up too much. F's go to 14. I don't even have room to write it, but F's go to 14. We probably will never use the F level, but if they do. All right, so any F. All right, so the way we did these last time, we wrote out electron configuration. When one level is full, you move on to the next level. When that level is full, you move on to the next level until you've put in all the electrons in an atom. All right, so these are the examples we did last time. If you haven't jotted them down, you might want to do it or something because I'm going to do a few more. And then once we do several, I want to point out something important to you. All right, so the first one I'm going to do of our new ones is I'm going to do, let's start off with sodium. We'll do a couple to get us started. All right, so for sodium, if I want to know where the electrons are in sodium, first thing I got to do, Na, I got to know how many there are. Well, it's element number 11. So we're going to be putting in 11 electrons this time. All right, so to be putting in 11 electrons, that means that I'm going to start with the 1s level. When it's full, I'll move on to the next level. I'll keep going until I get to 11. 1s, s's go to 2, 1s2. After 1s, you start the next arrow, 2s, s's go to 2, 2s2. After 2s, next thing you're going to fill up is 2p. P's go to 6. All right, so if you count right now, 2 and 2 and 6, I put in 10. So we're going to go to 11. Got one more to go. So after 2p comes 3s. It'll be 3s1. So that's the location of the electrons in sodium. All right, so you follow the arrows down. When you get to the end of one arrow, you go on down the next arrow until you've put in the correct number of electrons. All right. Oop, I meant to erase. Oh man, why is my eraser not working? There we go. All right, let's try. I'm going to do one more and then I'm going to get you to practice this a little bit. Okay, so let me show you one more. All right, let's move on to, let's do, what should we do next? Oh, let's do chlorine. What the heck? We'll do chlorine. Chlorine, element number 17. Keep going. We're going to put in 17 this time. Same pattern. You just go to 17. Okay, so 1s is always where you start. 1s2. After 1s, 2s. S's go to 2. 2s2. After 2s, we go to 2p. 2p6. Finish that arrow. 3s is next. 3s2. After 3s, I think we've only put in 12, so we got more to go. So we've put in 12 so far. So after 2s, we got to start going down the next arrow. we'll bump into 3p. And I think we need 5 more to get to 17. 2 and 2 and 6 is 10. 2 more. 12. Yeah, we need 5 more to get to 17. 2p5. All right. So same pattern, just going to 17 for chlorine. All right. With that, let me give you one to try. The one that I want you to try is Ni. Ni is right here. It is nickel. All right. So I'm going to do a few questions along the way to see if you can help me out with this one. First off, you got to know how many electrons are there. So in nickel, how many electrons are there? 28. It's element 28. Okay. So we're going to keep going down the arrows until we get to 28. So a little harder, right? Because there's more electrons, but same idea. All right. First thing to fill up. 1s. 1s, 2. After 1s, 2s, s's go to 2, 2s2. After 2s, 2p, p's go to 6. After 2p, 3s, s's go to 2. All right, right now we put in 12, so man, we got 16 to go. Okay, so now we're going to do 3p. That's the next arrow, 3p6. All right. What am I going to fill up next? What level am I going to fill up next? 4s. All right, 4s. S's only go to 2. 4s2. Now, if I count them all up now, 2 and 2 and 6, that's 10. Another 2, 12. 6 more, we're up to 18. And the last 2, we're up to 20. So we've got 8 more to go. All right. So what's the next level you're going to fill up? Should be 3d, I should say. Why do I keep saying that backwards? 3d, and it'll be 3d8. And that should add up to 28. All right. So with that, these are electron configurations. Now we got several examples here, and I think there's enough where I can show you something that's important about how this relates to the periodic table. Now, remember how we talked about way back in chapter 4, elements that are in the same vertical column have similar properties? Like boron is sort of similar to aluminum, which is similar to gallium and indium, right? Or beryllium would be similar to magnesium and calcium and strontium. Anybody in the same column is similar, behaves similar, looks similar. Now, why would that be? Why are those elements similar? Well, it actually has something to do with the way the electrons are arranged. All right, let me erase just a bit on this periodic table. And let's see, I have to tell you, I didn't just pick these examples at random. I sort of did them on purpose. If you look at the top of this list we've done, the first 3, I did hydrogen, and then we did lithium and sodium. They're all in the same column. They're all similar to one another. They behave similar chemically. Why? Do you notice anything that's similar about their electron configuration? They all end in S1. So the reason why those guys are similar to one another, I think we called them the alkali metals, is because they have a similar arrangement of electrons. You write something, 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 and the last thing you write for all of them is S1. They all end in S1. Now, if we go over to some other groups that we've done, they also are similar, and they're going to end in a similar thing. Now, again, I didn't just pick these at random. I also did oxygen and sulfur. Oxygen and sulfur, they're in the same column. What do they have in common? They both end in P4. So that would be true if I asked you to do selenium or technetium. Any of these guys would end in P4. The reason why they're similar to each other is that they end in the last thing. They have a similar arrangement of electrons. All right. Now, of course, I'm not going to have time to do every single element, but let me just point out a few more. So we also did chlorine. Chlorine ends in P5. Now, not only does it end in P5, every other element, all the other halogens are going to end in P5. All the other halogens are going to end in P5. Now, in the middle part of the periodic table, you can kind of see these are the S's, or well, I'll get to that in a minute actually. So this is the S column, S1, right? That was the hydrogen, lithium, and sodium. This column right next to it will end in S2. I'm talking about beryllium, magnesium, calcium. They'll end in S2. On the far right-hand side, that's where we find the guys that end in P. P1, P2, P3, P4, I'll write over this, P5, P6. So again, if you're in the same column, I can tell you what you're going to end in. If I asked you to do silicon, he's going to end in P2. And then the guys in the middle, I think we call those the transition metals. That's where all the guys that end in D are. D1, D2, D3, D4, D5, D6, all the way over. I'm going to show you a little more clearly on another slide what I'm writing out here. So, all right, so they end in D. If you're wondering, what about the Fs? The elements at the very bottom, the lanthanides and actinides, they end in F. And they go from F, and this would be like F1, all the way over to like F14. All right, so those are where you find guys that end in F something. All right, so with that, I'm going to show you a better picture of that periodic table in just a minute, I promise. Now, before I do that, I want to point out one more thing. Let me erase this for a minute. You'll see a nice picture of this in a second. All right, and that is, I just told you, for example, sodium ends in, what did I say a minute ago? S1. Everybody in that column ends in S1. Do you know what? I can do even better than that. Let's number these rows. Row 1, row 2, row 3, row 4, row 5, row 6, row 7. Not only would sodium end in S1, I can tell you it's actually going to end in 3S1. Go over and down and like where they meet. That tells you the last thing you're going to write, 3S1. Does that work? I think so. Let's talk about oxygen. He is in the second row, and these are my columns, P1, P2, P3, P4, P5, 6. He's going to end in 2, and then we go down. This is P4, it says there. I know it's a little messy. 2P4. He's going to end in P4. That's a 4. All right. So that's the way it always works. All right, let me show you that a little clearer. And then we'll see how we can use this just to make sure we're doing electron configurations correct. So let me flip over to the next slide and I'll show you this same idea written just a little bit better, okay? All right, so this periodic table has been printed. It shows you what I was trying to write, maybe not so neatly a minute ago. All right, so as far as it goes, what have we seen here? We've seen that if I want to know what's the last thing you write for an electron configuration, you can use that, you can figure that out based on the periodic table. If I ask you about chlorine, chlorine is in the third row down, and he's in the P5 column. So the last thing you're going to write is 3P5. It'll be 3P5. Something, 3P5. That'll be what chlorine ends in. Now, what if I asked you to do carbon? Carbon is in the second row down, and if you go over, he's in the P2 column. He'll end in 2P2. All right. Now, there's only one tricky thing about this. There's only one tricky thing, and that is, if you notice, these guys, if you're in the second, oh, well, let's do the third row actually, or fourth row, I guess. This guy ends in 4S1. He's in the fourth row. 4S2 for calcium. And if we go over here, yeah, this guy would end in, he's still in the fourth row, right? We're going across here. 4P1, 4P2, 4P3, and so on. But the D's are actually one behind. So if you are in the fourth row and you're in the middle section, like for example, iron, it doesn't end in 4D, D6. I know it's in the fourth row. You actually have to take one away. It'll actually end in 3D6. So the D's are one lower. If you go to the sixth row down, this guy is not going to end in 6D. He's going to end in 5D. The D's are one behind. All right, so we'll do some examples. Hopefully that'll help this make a little more sense. All right. So there's two things I want to point out to you. First off, you can use your periodic table to double check that that you are getting the right answer when you do an electron configuration, because if I ask you about argon, you know it's going to end in 3p6, all right? And the other thing I want you to realize from this is that if I want to understand why the periodic table is working, well, it has to do with this idea. If you're in the same column, you are similar because everybody else in that column ends in the same term. It has a similar arrangement of electrons. All right, with that, let's do just a little bit more practicing in this video of writing out electron configurations. So let me go to a new sheet of paper and we'll do that. Oh, and before I do that, I just realized I have one more picture that might help you see this, right? So if we go down the periodic table, this is row 1, 2, 3, 4, 5, 6, 7. And again, in the second row, they end in 2. In the third row, they're going to end in 3. But when we have this middle section, they're one behind. The fourth row, they end in 3D in the middle, and then it goes back to 4P. So it's 4S, 3D, 4P like that. Fifth row, these guys would end in 5, 5S, 4 in the middle, 4D, and then this is back to 5 over here, 5P. All right, hopefully that's making sense. We'll do some examples. That should help. All right, let's do them now. We're going to do our last two examples in this video of writing out electron configurations. Where the heck are the electrons in an atom? Where the heck are the electrons in an atom? All right, so this time we're going to do the same thing, right? We're going to follow these arrows down, 1s, 2s, and all that. But we now know that we can confirm that we've got the right answer based on where an element is on the periodic table. All right, so with that in mind, let's get to our example. So let's say I wanted to write out the location. Where are the electrons in magnesium? Magnesium is right here on the periodic table. It's element number 12. It's got 12 electrons. So we're going to write something, 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 something. What? Oh, let me number these while we're here. What is the last thing you should be writing? Something, something, something. It's going to end in. It should end in. That was the S's here. Magnesium should end in 3s2. All right, if we do it right, we better end in 3s2. If we don't end in 3s2, we goof something up. That column, the second one over, ends in s2. And specifically, it's in the third row, so it would be 3s2. Let's do it. So, following our arrows. Oh, rats, I mean to erase. Come on, dude. All right. So, following our arrows. 1s. 2. 2s. 2. 2p. 6. P's go to 6, don't they? And then the next thing we're going to fill in is 3s. 3s2, I think. All right, so does that work? It's supposed to add up to 12. Let's check. 2 and 2, 4, 6 more, 10, and 2 more, we're up to 12. All right, so that is the electron configuration for magnesium, and it's matching up with what it should be based on where it is on the periodic table. All right, let's do one more. All right, I'm going to do one more, and this one, man, this is one I'd make you do if I was having a bad day, because it's kind of a big guy. But hey, let's try a hard one, all right? We might as well. Zr, zirconium, element 40. We're going to have to put in 40? Yeah. Okay, let's do it. All right, so there's 40 electrons. All right. Do you know what it's going to end in? At least you'll know what it ends in. Man, there's a lot to put in, but what is it going to end in? Let me give you a little hint. Oh, let's write those back in. P1, this was P1 through P6. These guys were D1 through D10. So what's it going to end in? So D1, this is, man, I'm giving you lots of hints. Look at where it is on the periodic table. It should end in D2. Now be careful. Remember the D's are one behind. It should end in 4D2. I know we're in the fifth row, but the D's are one lower. It should end in 4D2. All right, let's do it. So in the interest of saving us a little time, and you've seen a bunch of these, I'm just going to do it real quick. Let's just see if we can get it done. 1s, 1s2, 2s, 2s2. After 2s, 2p, 2p6. After 2p, 3s, 3s2. After 3p, we get to 3s, you get to 3p, 3p6. Shoot, I'm running out of room. I'm going to keep on going down here. 4s2. After 4s2, hit the next arrow. 3d10. After 3d, you get to 4p, 4p6. After 4p, 5s2. And after 5s, the next level you fill up is 4d, and it should be 4d2. Now let's confirm we got it right, because all those exponents should add up to 40. 2, 4, 10, 12, 16, 20, 30, 36, 38, 40. That's the right answer. All right, so with that, that's all we're going to do on this topic. There is going to be the next video. We're going to kind of look at these in a little bit different way. So if any of this doesn't make sense, let me know, and I'll try to help you out. But as far as writing them out like this is the, I'm going to move on to something else in the next part. So you can always rewatch it or whatever. The only other thing I want to mention before I forget, there are a few elements that are exceptions to what I'm teaching you. I'm going to try to avoid going over those exceptions in class. There's a chance in sapling they'll bring those up. So be aware, once in a while, things go a little out of order compared to what I'm telling you. We're not going to get into it in much detail, but you might run across that in sapling. All right, so with that, that's the end of our lecture, this part of the lecture. We'll move on to part B in just a minute.